Okay, so the equation we had was mu k equals fk over fn, and so we are going to solve for fk. So we're going to sort it. We're going to have mu k times force normal equals fk, and then we will take mu k is 0.1 times force normal, 98.1 newtons, and this is going to give us 9.81 newtons. Okay, so this is our FK. So now essentially with our box in the y direction, so if you look up here, the FG and FN are equal but opposite, so it's actually going to be 0 in the y direction because they balance each other out. So the only thing this box is feeling is the force of kinetic. So it's going backwards, Fk. So the only force that's being acted on it is Fk, which is 9.81 newtons. Since it's going left, it'd be negative. So this is our force. So we have force, we have the mass of the box, we have velocity initial, we have acceleration. In the y direction, sorry, you don't need that. We have velocity final. And so you have all those things. And so what I'm going to do is use all of those equations. And if you notice, you have force and you have mass. So you can use F equals ma. Although it's not really asking for the acceleration, you can still solve for it. So you can have F equals ma. If we're going to solve for acceleration, this would be in the x direction. Notice it's going left and right. We're going to take force divided by mass equals acceleration. So negative 9.81 newtons divided by the mass, which was 10 kilos. We will get 0.981 newtons, and it is going to be negative. It'll be accelerate. So it'll be slowing down. Sorry, that should be meters per second squared, because it's an acceleration. So we have acceleration, and now with that, what we can do, since we have acceleration, we have velocity final, velocity initial. I'm going to use one of our older equations. Since we don't have time, I'm going to use, it's the equation Vf squared equals Vi squared plus 2ax. We have Vf, we have Vi, we have A, solve for x. So I'm going to sort this. So Vf squared minus Vi squared divided by 2a is going to equal x. We're going to plug this in. 0 meters per second squared minus 2.2 meters per second squared divided by 2. And then it's also going to be divided by our acceleration we found, which is negative 0.981 meters per second squared. And you should get 2.47 meters. And that would be the distance.